Do you want to create a high quality unstructured meshes in OpenFOAM? In this video, I'll take you through SnappyHexMesh from setup to mesh generation. Hello everyone, my name is Mukul Chandra and I welcome you all to CFD Simplified, where I simplify CFD concepts for you. If you are new here, don't forget to subscribe and hit the bell icon for more OpenFOAM tutorials. SnappyHexMesh is a meshing tool in OpenFOAM that generates complex meshes around 3D geometries. Unlike BlockMesh, which creates structured meshes, SnappyHexMesh refines and snaps the mesh to match the surface of an imported file. Okay, so now I'll be giving you the tutorial of SnappyHexMesh. Alright, and after that I'll be telling you things about inside what is there inside snappyHexMeshDict. Okay, same things are there, like a blockmeshdict is there, a snappyHexMeshDict is also there. Okay, so let's make one, go inside the tutorial, and let's learn how to use the SnappyHexMesh. Okay, so first I will go inside OpenFOAM tutorials by typing this command. As you know, if you are following my videos, then we will just a minute, right? Yeah, so then we will go inside mesh. Okay, and after mesh, just a minute, I was wearing my smartwatch, so it was just not helping me to type in a good way. Okay, so now we will go inside SnappyHexMesh. You can see one SnappyHexMesh directory is there, so there you can find as many example of SnappyHexMesh. Okay, so I'll be taking this tutorial, sphere gap closure. Okay, so let me take it. ls cd sphere gap closure. Okay, and you will go inside, you will find the files. Okay, so let me copy it first to my home directory, because I don't want to do anything here, because this is the main tutorial and I don't want to disturb these files. Okay, so let me copy this. So I'll copy by cpr sphere gap, and then I will give the path of my home directory, home Mukul. Okay, yeah, so it has been copied. Let's go to home directory. You can see sphere gap closure is there. I will open it. Okay, now if I will go inside this system, there you can find snappyHexMeshDict. Okay, so first let us go inside it. Yeah, so you can find that one file is there. This is known as sphere with hole.stl. Okay, how you create this file? You can create this file in any of the 3D modeling software. Okay, and save it to .stl format. Alright, after saving it, you have to copy that file. Uh, just a minute. Yeah, after making that stl.stl5, when you wanted to use that file in the OpenFOAM for the analysis, you need to first copy that file inside the constant, inside the, there you can see one try surface directory is there. Okay, so you need to copy that stl file inside the try surface directory. Here you can see that .stl file is being there. Okay, this is a tutorial, so they have made it easy for us, so they have copied this inside it. Always, if you wanted to use snappyHexMeshDict, always you have to keep this .stl file inside try constant try surface directory. Okay, and you have to mention about this the name of the file in the snappyHexMeshDict, which you can find inside the system directory. All right. Okay, so all right, so uh, uh, now how to use it? Okay, so first you have to make a rectangular mesh. Without rectangular mesh you cannot use snappyHexMesh directly. Okay, and how you can make a rectangular mesh? By only typing this block mesh command, which we have learned in the previous video. Okay, If you have not watched that, please go and watch that video. All right, I will type block mesh. It will create the rectangular mesh. Let me show it to you in the para view. So first I will make .foam file, and then I will type paraview.exe foam.foam, press enter. Because I am using, yeah, one thing I would like to tell you before opening it, like the general way of opening the para view is para foam space the name of the file, okay, foam.foam, okay. But we are using it in Windows. I am giving the tutorial in Windows, okay, so that's why I have to open it like paraview.exe foam.foam, okay. You can open parafoam also, but it will, there is something which, that's why I'm using paraview.exe, that I will tell you afterwards, okay, that I will tell you afterwards in some other video, okay. And that parafoam you can use while you are installing Ubuntu via this Microsoft Store. I've told about this, why I recommend to not to install Ubuntu via Microsoft Store in your Windows system in our first video of how to install OpenFOAM. Okay, just go and watch it if you have not watched. Okay, yeah. So I've opened like this, okay, and I'll be opening like this in my all upcoming tutorials. If I get some time lucky, and if I get in touch if in with any of the system which has stored Ubuntu in their system, okay, then I will tell you the things there. Okay, yeah. Let me open paraview, press apply. Yeah, if you open the go inside the wireframe, you can see your mesh. Okay, so this is the rectangular mesh which you have created with the help of the block mesh command. All right, now what it will do, it will insert that sphere which is going to we are going to use. Okay, so let me open that sphere. Okay, let me show you what is that 3D model is there, which we have converted into .stl file, and that 3D model we are going to insert inside this rectangular mesh. Okay, so let me open that. So for opening that, I will use one open source CAD software which is FreeCAD. So let's open it, and then I will it will take some time to load. Let's wait. Yep, it is there. So I will go inside file, click on open, then I will go inside Linux, Ubuntu, home, my name, and I will go inside sphere gap closure, constant, try surface. I will select this file and press on open. Yeah, you can see that this is the 3D model. This is the .stl file which we will be using for creating the this type of mesh inside our rectangular mesh. Okay, inside our domain, whatever the study is, that we are not focusing on it. Okay, we want this some problem is there, and we want this to be inside our mesh. Okay, so for inserting this inside our mesh, because block mesh can only create a structured rectangular mesh basically. Okay, it cannot make this circular, spherical, and this type of mesh. Okay, so we are going to make this type of mesh by using SnappyHexMesh. Okay, let me close it, and yeah, I will close paraview also. Okay, yeah. So now everything has been set up. We have run the block mesh. Now I will just give the command of snappyHexMesh and press enter. Okay, it will take some time to complete, only I think 10 to 15 seconds. Yeah, it will be completing. Yeah, it is completed. Okay, now let us again open paraview. Okay, and yeah, it is there. I will press on apply. Yes, you can see that the mesh has been converted into the sphere. Yeah, you can see that. You cannot make this mesh with the help of the block mesh. If you go inside, if I'll zoom in more, then you can see, you can see the patterns. Okay, these type of patterns, yeah, like this these diagonal patterns, you cannot make this with the help of the block mesh. Okay, block mesh can only make the rectangular box. So what it has done, it has done, yeah, this specifically this tutorial has removed that rectangular mesh, and only just involved this snappy hex mesh, this sphere, and remove that rectangular part. Don't worry about that, don't worry about that. It happens. It is like for this exam, for this tutorial, it is like that. But one day I will make my video, my work video, which I have done in MTech. So there what we have done is like we have just kept the first, we have made a rectangular mesh, then with the help of snappy hex mesh did, I have just inserted a circular pipe inside it. Okay, so rectangular mesh was there, and in between circular pipe, circular hole we have made for the analysis. Okay, so this was the tutorial of the snappy hex mesh. Let us try some other examples which were there inside the snappyHexMesh tutorial directory. Okay, let us make it. Let's go backwards, and I will again open foam tutorials. Yeah, you can go inside mesh, you can go inside snappyHexMesh. Okay, like in this example, like this is sphere gap closure which we have done right now. Here you can find the .stl file was there inside the constant directory, but in the other tutorials the .stl file is not there. Okay, I don't know why this type of thing they have done. I'm very unhappy with this type of thing of the OpenFOAM, what they have done in these tutorials, but this is it. Okay, like if I'll take the example of igloo, you must be knowing about igloo. Okay, so if we'll go inside igloo, and yeah, you can see that no constant directory is there. So you have to first create the constant directory, and inside the constant directory you have to create tri-surface directory, and then there the .stl file you have to paste. Now where you can find that .stl file? Okay, it is there, inside one directory is there. You can go backwards, and here you can find in the tutorials you can find one resources directory is there, resources. Okay, so here inside the geometry you can go and you can find one, this fridge a dot emesh. Yeah, so the file can be with the extension like .stl .emesh .obj, means obj means object. Okay, so these three are the useful file extensions for creating the mesh with the help of the snappy hex mesh. Okay, so this one. So now your question will arise that how do you know that this file, because there are many files. So, .stl .stl .obj, how do you know that this is going to be used in igloo? Okay, so I know because I have been gone inside the all run file. We'll go again inside the mesh, open the snappy hex mesh, go inside the igloo, and when you go inside all run, there you can see that it is first copying from resources this file. Okay, so that I know that this file is going to be used for making the snappy hex mesh thing. Okay, so yeah, so we'll be also doing the same thing. So first let me copy this igloo one. So I'll press cp -r igloo, and then I will paste my home directory path, home home. Okay, then I'll press enter. Now it has been copied. Okay, and then I will okay, so you know, now I have to first make the directory, the constant directory, and inside that the tri-surface directory, and after that then I have to copy this. So I'll open a new terminal. Okay, so how to open the new terminal with the help of from the WSL? Just click on this drop down arrow which is coming, click on this and go on Ubuntu. Okay, yeah, so you have again open a new terminal. Okay, so here we will open the igloo one, because again we have to go back and then we have to come back, so that is not the way of doing the things. Okay, so we can just, because we have to type lot of commands. Okay, there's nothing type of clicking and going back. Okay, yeah, so here it is there ls, and then here we can make directory constant. Okay, it has been created. Now I will go inside the constant, and again I will make try surface. Okay, try surface has been created. So okay, we will go inside the try surface, try. Okay, and press pwd for the path, and I will just select this one and press Ctrl Shift C to copy. Then I will go back and I will go inside the resources directory, resources, and then I will go inside the geometry, press ls. Okay, now I have to copy this here. Okay, so simple, we can do type cp -r fridge and press tab, yeah, and then right click to paste the path of the of the directory where we wanted to paste this fridge a.emesh and press enter. Okay, now if I'll open this terminal and press ls, yeah, it is there. Okay, it is there. All right, so now it will be simple. You have made the try surface, you have made the constant, you have copied that .emesh or .stl or .obj file. Now only thing is, first make the block mesh has been created. Let us see what type of rectangular mesh is there. So for that we will open this foam. Okay, yeah, press apply and go inside the wireframe. Yeah, so this type of rectangular mesh is there. Okay, all right, we have successfully created rectangular mesh. Now we will create the whatever is there to be created with the help of snappyHexMesh and press enter. Okay, so it will take some time to get completed. Yeah, it is completed. Now again we will just sparaview.exe, foam.foam, and press apply. Yep, I will again go inside the wireframe. Yeah, you can see that rectangular mesh has been removed, or it was there or something like that, and they have inserted this. Okay, so this is the igloo, and inside that two fridges are there. Okay, two fridges are there. All right, so like this you can create your snappy hex mesh. Use the snappy hex mesh for the creation of any type of unstructured mesh you want to create. Like for example, for the you must have, if you type OpenFOAM, you will see one image of bike and what drag forces are going on inside that. You can create that bike. First you just create a rectangular mesh, and then with the help of the snappy hex mesh, insert that bike inside that rectangular mesh. Okay, so that rectangular part will behave like a wind tunnel, and inside that one small model of bike is there, and then you can perform your analysis. I think that type of tutorial is there inside the this the OpenFOAM. Okay, if we'll go inside the mesh and snappy hex mesh, yeah, motorbike leak detection, this one is there. Okay, so yeah, so it must be something or something like that. We will look into it. Okay, I will try to run the whole simulation of this one. Okay, so there you can you will be able to learn more. Okay, you will be able to learn more. All right, so this I wanted to tell you about how to use snappy hex mesh. Okay, this is the way, this is the process, this is the steps you have to follow to use the snappy hex mesh. Okay, all right, so let's talk about the snappy hexmeshdict file, because without the explanation of this, I think snappy hexmesh tutorial is not complete. So let me explain about these. So I'll start with with this one. So yeah, let's just start from here. Okay, so as you can see, as I've told in the block mesh video also, if you've not seen that, please go and watch it, because that is a very important tutorial for because without block mesh you cannot snappy hex mesh is of no use. Okay, so please go and watch it first, if you don't know about block mesh yet. Okay, so yeah, but till here all the things are same, only in the object type it has been written snappyHexMeshDict. Okay, then it is coming, the next one is castellated mesh. Okay, second one is snap, and third one is add layers. All right, so what is this? Basically, this castellated mesh means that it uh, enables the initial mesh refinement. Okay, like for example, if you are using the snappy hex mesh, so it is snappy hex mesh. What is snappy hex mesh is is usually doing, it is just putting an 3D object, a 3D, you can say 3D surface, or the surface which you have made, okay, using any 3D software. Okay, inside a rectangular mesh. But if it is put like that, it will distort the mesh. Okay, it will disturb the structural meshing, and the distorted mesh, it will be a very bad mesh. Okay, so we need to refine it. Okay, we need to refine it. So for the refinement, this castellated mesh is being used. Okay, next comes to the snap. Okay, so snap means like it converts the the rectangular mesh, not converts, like we can say, yeah, adjust will be the will be the perfect word for this. So it adjusts the rectangular mesh according to our geometry which we are putting inside the this inside a rectangular mesh. Okay, like for example, we have put this sphere one, right? Let me open it. So, or a sphere one, or I will open my case. Okay, yeah. So I will type paraview.exe, foam.foam. Let's wait to get it open. Up, press apply. I'll choose wireframe. Yeah, okay. So I am a very I am using this from the last 2 years, but right currently I'm an ANSYS, so some ANSYS, if you wanted to move the surface up and down, you have to press Control and then there's a scroll button on your mouse. Here only you have to press a scroll button to move it up or down. Okay, so this is the thing. All right, so yeah, so you can see that this what does the snap option, the snap sub dictionary of the snappy hex mesh do is like it adjusts the rectangular mesh according to the geometry. How? You can see that here it is the circular portion, before that it was rectangular one. Okay, we have inserted the circular part, so what it has done, you can see that it has made the mesh somewhere circular. Okay, and here it has adjusted it like way that it has become rectangular after some part. Okay, so this is the use of the snap part. All right, add layers, basically if you want to add boundary layers, for example, if you are doing any case of for example aerofoil. Okay, aerofoil, you need boundary layers. All right, but in this case, in the sphere one which we have generated in this video, we do not need to add any boundary layer, so that's why it has been put false. Okay, if you want to add layers, then you can put here true, and then it will start adding the layers. Okay, now yeah, so here you have to define this this dummy. If you want to put, you can put. If you don't want to put, you cannot put. Here they have put because we can say that it is just like a placeholder where the actual mesh is created around. Okay, this is like a, for example, like a dummy box it has made, and inside that dummy box this sphere surface is being created. Okay, like in the whole rectangular box they have made one dummy box, and inside a dummy box this is happening. Okay, so this is what they're trying to do, but it is of no use. I mean, if you wanted to make it. If you don't want to make it, still the according to my experience, it can be generated. Okay, it can be generated. All right, so yeah, let's come to the castellated mesh controls. Here you can see some terms: maximum local cells, maximum global cells. Okay, minimum refinement cells. All right, so these minimum refinement cell, maximum load and balance, and cells between levels. Okay, that's fine, but the main important points are these two: maximum local cells and maximum global cells. Okay, so maximum local cells basically is because sometimes what happens is like snappy hexmesh requires parallel processing. Okay, what is parallel processing? Parallel processing means running the the simulation, the CFD processes on multiple cores. Okay, like for example, if you are just I'm running it normally, so it will be using the single core of your CPU. But if you wanted to run it parallel cores, okay, then in the parallel cores it will use all the four cores. Okay, so maximum local cell means like it is putting the limit of maximum per core. Okay, like for example there are four cores, like in my laptop there are only four cores. Okay, so in that four core, a single core can only make how many is there? It's 100,000, right? Yeah, 100,000 cells. A single core can make 100,000 cells. Okay, this maximum local cells known. Okay, and what about this maximum global cells? So maximum global cells is the total mesh limit. Okay, like in the whole mesh, how many, what is your maximum limit you are putting? Okay, so that is this, and how much this is? I think it's 2 million. Okay, ones, tens, hundred, let me count it: ones, tens, 100,000, 10,000 lakh. Yeah, I think it's 2 million cells, if I'm not wrong. Okay, yeah. So this is there. I'll be skipping these three minimum refinement cells. It is written here, but we'll look into it afterwards. Okay, we'll look into it afterwards. Then it comes to the refinement surfaces. Okay, so refinement surfaces means what around the which do you want to have any refinement around the surface? Yes, it is required, because you can see that if in my case, in the cylindrical pipe case, the refinement is being required, because if it is not made, if the refinement is not being done, what will happen? The mesh will not be good. Okay, it will be a very distorted, very bad mesh. Okay, so to make the refinement around the surface, okay, that this refinement surface is being required, and to how much level you wanted to this make the refinement, that levels you have to define. Okay, like we want level up to level 5, we want the mesh refinement. Okay, then it comes, then we, the important point is location in the mesh. Yes, where do you want to put the surface you are generating via snappy hex mesh? Like for example, if I'll talk about this cylinder. Okay, according to the case, according to the problem, it has to be put here. Okay, but it has to be defined. Our OpenFOAM doesn't know. OpenFOAM doesn't know by its own that this cylindrical hole has to be put here. We have to tell them. We have to tell the software. Okay, so how we can tell? We have to define the coordinates, that this is the position where I want the hole to be done, and that you are going to define here in this position. Okay, here like this is the case of the sphere. Okay, okay, let me open that one because I think if I'm not open, then it will be more confusing. Sphere, yeah. View.exe form. Okay, yep, yes, let me make it to wireframe. Yeah, so yes, so what we were talking about, we were talking about the location. Yeah, so before that it was like there is no rectangular part in the mesh, because I think it has all converted that rectangular mesh into this sphere only. That's fine, that's fine. Okay, but the position has to be defined. Okay, if you do not define the position, it will give you the error. If you will not define the position, it will give you the error. It the position, the definition the of the position is required. Okay, it's mandatory to be done. All right. Locations outside the mesh, for this case they have defined. Generally I don't think that has to be defined. Okay, so you can just go inside. Right now snap controls, as I've already told you, what does this snap controls means, like how smoothly the mesh conforms to the surface. Okay, if you increase the tolerance, okay, so it will more, try to refine more around the surface, try to refine the mesh more around the surface. Like for example, if we take the example of, because why I'm taking the example of this, because it contains both a rectangular mesh and the snappy hex mesh one. Okay, so that is, this one is the a very good example for that. So that's why I'm again opening this one only. I thought that this will be a very good, with the help of this a very good explanation can be given. Okay, so yeah, if the tolerance can be increased, you can see a very close one, or very it will make the mesh more, try to make the mesh more finer and finer around the surface, whatever surface you wanted to create. But what it will done, sometimes what happens is, like if you take the tolerance less, your results will not come. Okay, your some error, if you, specifically if you want, if you are running the turbulence case, so error will start coming, your current number will blast, your delta t will blast, and in the end it will start giving you error. Okay, so that can happen, so you have to increase some tolerance and everything, but that you have to, do it, you can do it up to a limit. Okay, because if you try to increase it, it will not give you, like it is not like directly proportional. Okay, it can give you the result up to up to certain level, because if you keep on increasing it, it will try to make the mesh more refined, and more refined means more finer, and more finer doesn't give you the guarantee of getting the good results, and it will use your, it will case more and more heavy, it will make the case more and more heavy, and it will put more load on your computing power. All right, so that's why the tolerance has to be adjusted as required, as per the case. Okay, as per the requirement in the case. All right, so this is the things is there. And add layers, as I've already told you, we are not doing it in this case, so we will not be defining here. And one more thing is there, this is known as mesh quality controls. So basically this mesh quality controls is being there inside the OpenFOAM main codes. Okay, so like some things, it can try to like if, when the snappy hex mesh is going to is solving, so it is trying to check everything, and then if error is there, it is trying to remove those errors by itself. Okay, so this is the part, this mesh quality controls is the part which is, trying to remove the errors in the while putting the, this any of the surface in the rectangular mesh. Okay, in the rectangular mesh. So you can see that n smooth scale is given and error reduction is given. Okay, so yeah, if some errors are used to coming if you try to run like SnappyHexMesh for a very huge case. Okay, like my case. Okay, I have to run this SnappyHexMesh on the parallel course. If I do not run this on parallel course, it takes time and it doesn't generate a very good mesh. Okay, so in one of the video I will make to like what was my work and how I have performed it. Okay, so I will make the full video and full like how I have generated the thing. So I will make it, don't worry about that. But yeah, I have to run this in parallel course. So I have to I was running this on the high power computing system at my college, IIT Jodhpur. IIT means Indian Institute of Technology Jodhpur, and there I used to run it on 16 cores. Okay, so yeah, if I do not run on multiple cores, like if I just put the command like snappyHexMesh after block mesh, I just put snappyHexMesh, it definitely it is going to give me the error. All right, so that is the thing. Okay, and other things are there. The things which I have skipped here, I think that I will define you when we will be doing a specific case, because I think doing that, explaining those things with the specific case will be a good explanation. Okay, so I have to find a, some cases, and then I have to make it, and then I will explain with accordingly. Okay, I will just show you in paraview, and then I will explain about that. So that will be give you a good explanation. Okay, so yeah, so this one, like I've given you the brief one, so you may have got a very good idea, I think, like how snappyHexMeshDict has been made. Okay, has been made. All right, so briefly you have got a good introduction. Some things are there. I will try to explain it, or you can read it also on internet, websites like OpenFOAM Wiki and others, like website like CFD Online. You can find the like the answers of your question on the CFD. Otherwise, I'll be telling in the in the coming videos. Okay, I'll be definitely telling about that. All right. So this was the thing which I wanted to explain about the snappyHexMesh. Now you know how to use snappyHexMesh in OpenFOAM. Try with your own geometries and experiment with the refinement settings. Like and subscribe for more OpenFOAM tutorials. Drop a comment if you have any questions.